40 seconds. That's all that stood between humanity and the most powerful rocket ever built, taking its first flight in a whole new form.
40 seconds. The countdown was running, the rocket was fueled, tens of thousands of people were watching, including a certain pop star who really should have been a good omen.
And then it stopped. Ground equipment issues, rising propellant temperatures, a scrub.
But here's the thing. Even in the scrub, SpaceX dropped a bombshell that had nothing to do with the rocket. A crewed mission to Mars. A real one, with a commander already named.
We have got a lot to unpack today. I'm Anna.
I'm Avery.
This is Astronomy Daily, May 22nd, 2026. Let's get into it.
All right, let's set the scene. Thursday evening, South Texas, Starbase. The brand new Starship version 3 is sitting on the pad, fueled, stacked, frosted white from cryogenic propellant, and the crowd has been building all day.
This was supposed to be Flight 12, the debut of the most powerful rocket ever built in its most advanced configuration yet. And for context, this is the first Starship test flight since way back in October of last year. 7 months of development work, 2 explosive setbacks on the test stand that destroyed hardware, and now, finally, here they are.
The launch window opened. Weather clears. SpaceX pushes to the back of the 90-minute window to wait for upper-level winds to ease, and then the countdown starts ticking toward T0.
And it gets to T-minus 40 seconds, and it stops. It restarts, goes back to T40, stops again. Engineers are on the webcast, working through it in real time. SpaceX communications manager Dan Hoot is telling viewers they're seeing issues with quick disconnect lines and water diverters on the launch tower.
And then propellant temperatures start rising in the tanks. That's the clock running out. The window closes, scrubbed.
A scrub at T-minus 40 is genuinely frustrating. You're that close. But it's also, as SpaceX themselves say, completely expected behavior for a brand new rocket on a brand new pad. You learn things about these systems that you simply cannot learn any other way.
So let's talk about what they're actually trying to fly, because Starship V3 is a substantial step up from everything that came before.
The V3 Starship, that's the upper stage, called Ship 39 in this case, and its super heavy booster, Booster 19, together generate around 18 million pounds of thrust at liftoff. That is a significant increase over the V2 configuration. New engines on both stages.
The mission profile for Flight 12, when it does fly, has Booster 19 splashing down in the Gulf of Mexico, while Ship 39 continues on a suborbital trajectory and targets a controlled splashdown in the Indian Ocean. And critically, the mission includes a Raptor engine test during the coast phase, important data for future deorbiting burns on orbital flights.
And if Flight 12 goes well, the word from SpaceX is that Flight 13 could be the first orbital Starship launch. That's a massive milestone. Now, there's a bigger picture here too, Avery. SpaceX recently filed for an IPO. The company is expected to go public within weeks, and Starship is central to that story. Demonstrating meaningful progress on the next generation rocket program right now matters in a very real financial sense.
The good news is they get another shot tonight. The launch window opens at 6:30 p.m. Eastern, closing at 8. Engineers have been working through the night on those ground systems. If you're listening to this and the window hasn't opened yet, watch the space.
And now the part that honestly might be the bigger story, because while engineers were troubleshooting at T-minus 40, the SpaceX webcast team did something remarkable. They cut to a pre-recorded interview.
With a man sitting on Bouvet Island, which, for context, is widely considered the most remote island on Earth, a tiny volcanic rock in the South Atlantic, a nature reserve. Population, 0.
This is Chun Wang, Chinese-born cryptocurrency entrepreneur, citizen of Malta, and the commander of the Fram 2 mission last year, the first ever crewed spaceflight to polar orbit. The man has form when it comes to doing genuinely novel things in space.
And SpaceX announced that Chun Wang has signed on to fly on the first commercial Starship circumlunar mission, joining Dennis Tito and his wife Akiko, who bought seats back in 2022. A loop around the moon on Starship.
But that's not the headline. The headline is what comes after the lunar flight.
Jun Wang will command the first crewed Starship interplanetary mission, a flyby of Mars, a 2-year mission. And in Wang's own words, a lot of people talk about going to Mars. We like Mars. We're going to land on Mars. We're going to build a colony on Mars. But let's get it started with a flyby. It will light the fire. It will ignite the imagination. It will build the momentum.
No launch date was given, no full crew manifest, but a commander is named. A mission is defined. That's a real step beyond the language of "we intend to" and into the language of "this person is going."
Remember, SpaceX's own timeline has uncrewed starships launching for Mars in the November-December 2026 transfer window. The pace of this program, even with scrubs and setbacks, is like nothing we've seen before.
One scrub doesn't change any of that. It will simply become a footnote in space history books. What matters is that the rocket is on the pad. The ambition is extraordinary. And tonight, maybe tonight, Starship V3 flies for the first time.
And meanwhile, in other space news today, staying with the theme of extraordinary things happening in space, the James Webb Space Telescope has given us another one. Astronomers have directly imaged an exoplanet called Epsilon Indi AB, a cold super-Jupiter sitting about 12 light-years from Earth, and found something nobody expected to find there.
Water ice clouds, not ammonia clouds, which is what Jupiter-like planets are supposed to have. Patchy, thick water ice clouds, similar to cirrus clouds here on Earth, hiding in the atmosphere of a world 7.5 times the mass of Jupiter.
The discovery comes from a team led by Elizabeth Matthews at the Max Planck Institute for Astronomy, using Webb's mid-infrared imager, the MIRI camera, which was able to directly image the planet's faint heat emission. The planet orbits its star at roughly Neptune's distance from our Sun, making it far colder than most exoplanets Webb has studied. Surface temperatures somewhere between -70 and +20 degrees Celsius.
What makes this significant isn't just the discovery itself. It's what it says about our models. Current atmospheric models for exoplanets didn't predict water ice clouds in a world like this. They expected ammonia. The fact that thick water ice layers appear to be masking the ammonia signal means our frameworks need updating.
And it has practical implications for how we search for other cold planets. If water ice clouds make some wavelengths look much fainter than expected, we may be missing worlds that don't fit the standard brightness profile.
The researchers put it this way: JWST is finally letting us study solar system analog planets in detail. As lead author Elizabeth Matthews said, if we were aliens several light years away looking back at our sun, this is the first telescope that could study Jupiter in detail. We are living in the golden era of exoplanet science.
From 12 light years away to right here in our own galaxy, and a discovery that reshapes how we understand the invisible forces holding the Milky Way together.
Astronomers at the University of Calgary have produced one of the most detailed maps ever made of the Milky Way's magnetic field, and found something deeply unexpected hidden inside it: a magnetic flip. A reversal in the field's direction, cutting diagonally through one of our galaxy's main spiral arms, the Sagittarius arm.
The data came from a new radio telescope at the Dominion Radio Astrophysical Observatory in British Columbia, Canada. The instrument scans the sky at multiple radio frequencies simultaneously, allowing researchers to trace the galaxy's magnetic structure using a technique called Faraday rotation, measuring the way radio waves shift when they pass through magnetized plasma.
In most of the galaxy, the magnetic field flows in a consistent direction along the spiral arms. But in the Sagittarius arm, the team found a diagonal reversal. The field essentially flips orientation across a diagonal line cutting through space. This is the first time this structure has been mapped in 3 dimensions.
The finding matters because the galaxy's magnetic field isn't just a curiosity. It shapes where gas flows, where new stars can form, and how the galaxy itself evolves over billions of years. A detailed map of that field gives astronomers a reliable baseline for future studies that reach far beyond our own galaxy.
Lead researcher Dr. Rebecca Booth described it as revealing a hidden structure. What looks like empty space is anything but empty. And thanks to this work, the invisible architecture of our own galaxy is no longer just a theory. It can be studied, tested, and built upon.
And finally today, a successful launch close to home, at least for our Australian and New Zealand listeners.
Rocket Lab fired off another Electron rocket this morning from its Launch Complex 1 on the Mahia Peninsula in New Zealand. Mission name Viva La Strix. The payload was a synthetic aperture radar satellite called Strix-7, built for the Japanese Earth imaging company Synspective.
This is the 9th time Rocket Lab has launched a Strix satellite for Synspective, a relationship going back to 2020 and with another 18 missions already booked through to 2030. The constellation Synspective is building will eventually provide continuous SAR imaging of Japan and surrounding regions, data used for urban development planning, infrastructure monitoring, and disaster response.
Synthetic aperture radar is worth a quick note for those unfamiliar. It's a type of imaging that works in total darkness and through cloud cover. While optical satellites can't see through weather or at night, SAR satellites illuminate the surface with radar pulses and build a detailed image from the return signal. That's why Synspective called the constellation Strix, the genus of owls. They see in the dark.
The Electron rocket itself is now 70 flights into its operational life. Small, dedicated, reliable. It's become the workhorse of the small sat launch market. And this mission is a textbook example of what it was designed for. A commercial customer, a specific orbit, a clean deployment. Rocket Lab doing what Rocket Lab does.
And that is your Astronomy Daily for Friday, May 22nd, 2026. What a morning to be alive and following space news.
Starship V3 gets another shot tonight. A crewed Mars flyby has a commander. Webb is rewriting exoplanet atmospheric science. Our own galaxy just revealed a hidden magnetic structure, and Rocket Lab quietly keeps building humanity's eyes in orbit from a hillside in New Zealand.
If you're watching the Starship launch tonight, you can follow live coverage at SpaceX.com. Window opens 6:30 Eastern. And as always, all the links, show notes, and further reading are at astronomydaily.io.
If you're enjoying the show, a subscribe, a review, a share. It all helps us reach more space enthusiasts around the world. We genuinely appreciate every single one.
And before we go, a quick reminder about the special money-saving deal our sponsor NordVPN has put together for you as you think about upgrading or implementing your online privacy. We did it, and you should too. And currently for not very much money.
Do check out Deal and be surprised by how good it is. Just click on the link in the show notes.
I'm Anna.
And I'm Avery.
Stay curious. Keep looking up. We'll see you tomorrow on Astronomy Daily.